Okay, so the AP people totally love absolute value. And so when I ask people like, oh, what if you are trying to get the absolute value of like 7? They're like, oh, you keep it the same, Miss Brady. But what if you're trying to take the absolute value of 7? They say, oh, you make it positive. Except that function, that word doesn't work really well for if you are trying to um, like work with it. So let's think about this definition. What if you're trying to find the absolute value of some function? Okay, so really you've got two choices. You keep it the same or you make it positive. But you make it positive when the original input is negative. So really what you're saying is you're taking the opposite. If it's positive, keep it the same. But if it's negative, take the opposite. So let's write that. So if it's positive, keep it the same. So the output's the same as the input. If f of x is bigger than 0, and it's the opposite if f of x is less than 0. And if it's equal 0, it doesn't really matter. You can put the equality either place. Okay, so that really is helpful when you're thinking about limits. So let's look at this first limit. X is approaching 2 from the right. So we're not looking at every value for x. We're only looking right about here. So let's pick a number, like say like 2.001. So if we thought about taking the absolute value of 2.001 minus 2, this would be positive, which means we don't need the bars. This part is greater than 0. So this is the same as x approaching 2, because if we know the sign of the input, we don't need the bars. Okay, so because the input's positive, we don't need the bars. And we're like, oh, that just reduces. So this is worth 1. Now, if you're coming from the other direction, you're at 2 and you're coming from the right, or excuse me, from the left, you're looking at numbers like 1.999. And that minus 2 is a negative number. So if you're super close to 2 but to the left, this part is negative. And so the way you adjust if the input to absolute value is negative is you take the opposite. So we need the opposite of x minus 2. And the numerator is x minus 2. But these guys reduce, and we get the limit as negative 1.